All right, you've seen some examples of static electricity. You've seen a few, and I'm sure you know some examples also. However, static electricity's official definition that we're going to use in this class is going to be an imbalance of electrons that builds up but doesn't move. What do we mean by imbalance of electrons? Any ideas? What do we mean by imbalance of electrons? It's kind of like related to math when we say something called an inequality. Inequality uses a greater than and less than symbol. So I'm just curious, how is a static charge an imbalance of electrons? What does that mean? Do you have any ideas?
Like one thing has more electrons than the other thing.
One thing has more electrons than the other thing. That's cool. And if you're looking at this thing all by itself, it has more electrons than it does what? Protons. So when you have something that does not, and that has more electrons than protons or less electrons than protons, then you have a static charge. We're going to take a look at 3 different ways that you can build up a static charge. Now, you'll notice that this family right here is incredibly charged. Okay? Now, this isn't used to power a light bulb. It's not electrons that are flowing through a wire. It's just hanging out here. These people are all charged up. In fact, these people are probably very, very negative. They probably picked up hundreds of thousands, if not millions of electrons. And because of that, what do you see about them? What do you notice about them? Somebody that's charged, what do you notice about somebody that has a static charge?
Their hairdos.
Yeah, their hair starts to stand up and things like that. Well, that's easily explainable. If you get a lot of electrons, you pick up a negative charge. And if your body is negatively charged, your whole body picks up a negative charge, then your body doesn't like itself. Your body tries to get away from itself. Now, your body does not explode. The force is not that hard where all little chunks of you go flying in other directions. But parts of you that are capable of moving and that are light will. So for example, your hair, since it's all negative and relatively light, your hair will start to repel itself. And you're going to notice this because this thing right here is also going to flush you with electrons and give you a very, very negative charge and make your hair repel itself. In other words, it will start to do that thing as you're attached to it. When it does move, this charge will build up and build up and build up. But once that charge does move and those electrons make the jump, and I think we've already seen this. Did you see it with my nose? What happens when the electrons do move? Yeah, it makes a shock. Okay, so when these electrons move, we can say when they do move, you get a shock. So if you were to walk up and take the electrons from the Wysockies, like you were to walk up and with like a big metal bar and touch them, you'd take all of their electrons, and you'd hear that snapping sound. You might even be able to see the blue light emanating from where the electrons are passing. But the second you take those electrons, all their hair is going to go and fall right down. And since it's hot and it's electrical, so it messes with your nervous system, you can feel it. That's why you feel shocks. Okay, let's take a look at one very easy way that you can build electrons, and that's through friction. So we're going to take a look at each one of these things individually. Now, you already have the word friction written down, so you don't need to write anything new, except next to the word friction, we need to explain and give an example of how this is possible. I don't know if you can make out that picture from where you are. Can you make that out? Can you tell what that is, or is the picture taken too close? Okay. We've got the hair balloon thing. How many of you have done this before? You can just be honest. Okay. It's a little ghetto birthday party. Stick it to the wall. Yay! Happy birthday to you. Okay, great. So most of you have done something similar to this before. You take balloons and rub them on yourselves and then either use them to pick up your hair or stick them to the wall. And we'll talk about why they stick to the wall in a little bit. You can charge things up simply using friction. You can rub electrons from one surface to another, especially if those surfaces are things like wool or plastic or other things like canvas on a trampoline. That's curious. I need you to think of places that you've been shocked and raise your hand. Tell me where they are. And we can probably equate it to friction. In each of those bins, can we get 2 pieces of acetate, the plastic, and 2 pieces of the fabric? And we you should be in good shape. There should be those little plastic pieces somewhere in there if you dig around. Yeah, well, there should be a stack over there. All right, where have you been shocked? And let's see if we can equate it to friction. Now, I'm not talking about sticking your hand into an electrical socket or touching the metal or sticking a knife in a toaster. That's something different. That's when you're picking up an electrical current. Where have you picked up a static shock from? Where?
Trampoline.
Trampoline's a great example. How many of you have ever been shocked on a trampoline? Good. One of the main reasons why you do is how many of you wear socks when you're on the trampoline? Okay, there you go. There's one. So you got two things going on here. Anybody ever been shocked without wearing socks? I'm just curious. Okay, you can still get shocked without wearing socks.
Yes.
So let's check this out. If you take a look carefully at your trampoline, you have a whole bunch of fibers. Okay? Think of all the fibers that are on your trampoline. If you were to think of all those threads stitched together to make those fibers, that could be canvas or nylon or whatever it is. And now you're taking all those fibers that are interwoven and you're going like this with them. Do you have a lot? Do you have enough there? And a piece of fabric. They can be a variety. A couple per bin would be good. So now you're taking all that fabric and you're going like this. You're going, and every time you do that, that fabric rubs electrons from one portion to the other. And they're also attached with metal springs at the end. Can you picture the metal springs on the end of a trampoline? They might be covered over some sort of material, but they're there. So now all of a sudden you're putting metal into the mix, which can either take electrons or receive electrons. So basically, as you're hanging out on this trampoline, you are using friction, generating a huge electrical charge. Let's say you're picking up electrons as you go, okay? So you pick up all these electrons, and you don't get shocked while you're on the trampoline. Like while you're jumping, you usually don't get shocked. When do you get shocked? When you're on a trampoline. When do you get,
Sometimes I'm just trying to step off.
when you try to step off and you touch the metal? You're stepping off, is that where you get it very often? Okay, where else do you get shocked on a trampoline?
If other people try to shock you, like rub their feet on the trampoline.
Oh yeah, and then they can chase you around and do that kind of thing. Yeah, and again, we're just using friction. We're taking fabric and putting it on other fabric, and better yet, putting metal or rubber into the mix also, and then you're transferring those electrons. Yes?
Can I like run around the trampoline but get shocked?
When you are on the trampoline and run around on it, yeah, same thing, especially with socks on will be good. Great, other than trampolines, where do you get shocked? Just curious, think about around your house or any other situations. What?
Can I rub the balloon on my dog?
There you go, balloons. Balloons we've already seen. These things are great at picking up electrons. So balloons will do it. Anywhere else? What?
When I try to
Turn it on the TV in a room that's carpeted? Yes. Especially if you're getting up off the couch? Oh yes. Especially if you're getting off the couch wearing wind pants, which are like warm-up pants. Oh yeah, we got a whole lot of good stuff going on. Okay. How about this? Coming back from practice. You have a practice where you wear wind pants, like nylon pants, and then you sit on your car seat, and then you, not a car seat, like you sit in the seat of the car, and when you go to touch the metal doorknob on the car, that'll get you sometimes. Where else? Where else? Where else? What?
Mrs. Sano's room.
Mrs. Sano's room, because it's the only rooms that are carpeted. Library, you can get it too. Very rarely going to pick up a shock in here. Today you will actually be shocked in here, because I'm going to do some stuff to be able to get you jacked up along those lines. Anything else? Yeah. Okay, I'm going to tell you my favorite. I live in the village of Liverpool, okay? And they have the Wegmans Playground. Have you ever seen that? Liverpool, it's near the skate park. Okay. Wegmans Playground. I love it when my kids go down that slide over and over again, because those slides are plastic. And they wear their fabric pants as they go down the slide. And as they do, they rub their butt all the way down that slide over and over and over again. When they get to the bottom, their hair is like this. My youngest son is like the holder of charge. This kid can build a static charge like nobody's business. He goes down that slide once, sits on the bottom, his hair's like this. And then he chases around his older brother with all those electrons. Zap, gets him, hair falls, and then we're good to go. Let's see if you can build up a static charge using friction. Here's what I need you to do. Now, be careful here. Touch your fingers. When I say be careful, I mean don't touch anything yet, if you don't mind. You don't have to be careful along the lines of you hurting yourselves. What you do need to be careful of is the ability to follow directions while you have stuff in front of you. Okay, I know you're going to be tempted to talk, but we are doing this in the middle of a journal entry, which should work out pretty well. We're going to give each table 2 scissors. Okay, I'll grab half. We're going to give each table 2 pairs of scissors, and what I want you to do is cut off like a triangle corner from your journal. Ooh, sorry, okay? Okay. Cut off a triangle corner of your journal about the size of maybe like a nickel or a quarter. Do you know what I mean? Just cut off like a triangle corner. And it shouldn't be, shouldn't be that big. Now when you got that little triangle, that's perfect size right here is good. It doesn't even need to be exactly a triangle. I just thought it'd be easy to cut a triangle for you. Once you get a triangle about this size, I want somebody in the group, somebody with a pair of scissors, and I think you got 2 of you in the group, to just cut it into like maybe 10 or 12 pieces. Okay, so go ahead, cut it into 10 or 12 pieces. Now, some people in the group now have nothing to do. Okay, you're just watching your partner there cut up paper. That's not too exciting. So what the other people are going to do is I need you to grab a sheet of acetate or a piece of plastic here, and I need you to grab a piece of fabric. What we're going to do is we're going to steal some electrons from the fabric and put it onto the piece of plastic. But here is the best way to do it. Don't do it yet. You want this to work well, you need to go like this. You're going to obviously grab it like this. About maybe 30 times or so, I want you to do this, but go in the same direction every time. Okay? So do this, but go in the same direction every time. Let's say 20 or 30 times. Okay, will be good enough. So now everybody's got something to do. All right, you're either cutting into 10 or 12 pieces of paper, or you are doing that thing about 20 or 30 times. Cool, once you get about 20 or 30 times done, what you're going to do is you're going to see if you've put a negative electrical field onto the sheet of plastic there by bringing it kind of close to your sheets of paper, but not touching them. Okay, don't touch them. See if you can get them to behave oddly as they enter that negative electrical field.
Oh, there's another thing in there too.